Thanks, Robin. Kia ora tātou. So I'm talking to you as our New Zealand delegate to SCAR, and that means that I attend the delegates meeting on behalf of the country, and put forward our views and our votes on particular issues. So, for those who may not be aware, SCAR is not only a supporting committee to the Antarctic Treaty, but it's also an affiliated body of the International Science Council. So it's kind of got two hats that it wears to function, and within that there's 46 member countries to SCAR and 10 scientific union members. So quite a good representation around the world. And in carrying out its work, SCAR kind of has three parallel purposes. The first, of course, is to initiate, develop and coordinate high quality international scientific research in the Antarctic region. And the second is to provide policy advice to the treaty, to the Committee on Environmental Protection, to CAMLR and to other UN agencies. And third, but certainly not last, is to support its members in their Antarctic research ambitions. And that's particularly through things like capacity building, fellowships, and supporting the science meetings where the science gets discussed and shared between nations. So that's a quick intro to why SCAR exists. And just thinking about how it operates, and I think it's useful before I get into the delegates meeting that just happened in Punta in Chile. They kind of operate in a couple of different ways. One is they have discipline-based research groups or science groups, and those are, of course, the life sciences, the geosciences, and the physical sciences. And they comprise a range of action and expert groups that are working on particular issues between the countries. And then they have the scientific research programs, which are a bit more interdisciplinary, work on specific outcomes, advancing specific needs around science. And at the moment, and you're going to hear from Tim on one of those, they include Instant, AntClimb Now, and Anticon. So the first one, of course, is about instabilities in the Antarctic ice sheet. The second about how the Antarctic's actually responding in the current climate system. And the last one about how we are going to progress conservation and policy around Antarctic species. So those are the three current groups. Now, every 2 years, the delegates meet to hear progress around those science groups and the action groups within them, and also the scientific research programs. And also they meet to work out, okay, how are we as SCAR going to do our work? And at a high level, that's articulated in the strategic plan, which is revisited every 5 years. And you can go online to the SCAR website, which is just scar.org, and download the strategic plan and have a look. And then the delegates work on, well, how are we going to operationalise that? So our most recent strategy is relatively new. It was agreed in 2023 and runs through to 2028. And of note in that, I mean, you can have a read through it, but Appendix 4 kind of focuses on the urgent needs of research. And one of the key things in that space is the growing uncertainty in how Antarctica and its physical systems and its ecosystems will or is already responding to changing climate. And then in parallel with that, really the respective policy implications and obligations required of the treaty partners based on the scientific evidence. So that's kind of the biggest sort of focus on what's urgent right now with SCAR. So with that, I'll jump to what the delegates considered at their meeting in Punta last month. They considered a couple of new members. We had applications from Colombia and from Belarus, and the delegates supported the application from Colombia, but not Belarus. Belarus's application was not considered ready by the delegates. and that's for full membership. They're already associate members. That was for full membership. Then they moved on and elected a new president and a couple of new vice presidents. And for those who haven't heard the news yet, I'm the new president, so I'm wearing the president of SCAR hat as well at the moment. From New Zealand, we also elected as a vice president Carlotta Escutia, who many of you may know from Spain, and Takuji Nakamura from Japan. So actually quite a strong representation of geoscientists now in the SCAR vice presidents and presidency, which is an interesting evolution to see. So hopefully we'll see that having a bit of benefit for the geosciences. We heard reporting from the science groups and research programs, and the delegates approved a new scientific research program, AGATA, Antarctic Geospace and Atmosphere Research. And so that's a fourth one added. But also through the reports of the science groups, they considered 2 new planning groups for scientific research programs. And I can get information to people who wish to know more. One is called Antarctic Geological Evolution, AGE, and the other is Changes in Circumpolar Antarctic Gradients and Ecosystems, CCAGE. So those are now planning groups to develop a research program that can make application and may be supported at the next delegates meeting in 2026. The other thing of note, and this was led by New Zealand, was an action group around groundwater across each of the life sciences, geosciences, and physical sciences. And that's quite an emerging issue. It was well received by the delegates, and so now that's going to be led out of New Zealand, but with members around the world to kind of develop a better understanding of how the groundwater system's evolving as we warm the Antarctic up. Couple of other action groups. One focused on diseases and wildlife, which of course will include the avian flu, and Scarfish, which is an action group on fish to support SCAR in Kamilar. And the last action group approved was around carbon emissions management and strategy for SCAR and how we deal with our own carbon footprint and how that fits into our scientific understanding. And Tim also sits on that, and so may be able to answer some questions on that. Other things of note at the meeting, that one of the things we talked about were plans for the IPY in 2032, 2033, and what we might do to develop kind of what science we might undertake in that. And of course, that's it's both poles, it's not just the Antarctic. And leading up to that in 2030 will be a joint meeting of SCAR and IASC, that's the Arctic equivalent of SCAR. And so there'll be some sort of final planning happening there. That meeting will happen in 2030 in Korea. I guess other meetings of note that were agreed to next year in 2025 will be the Symposium on Antarctic Earth Sciences in Punta. And the next Open Science Conference meeting will be in Oslo in 2026. And of course, a delegates meeting with that. SCAR Biology, for those interested, will be in the USA in 2027. And then the next OSC 2028 in Bulgaria. So if you've got your calendars up to date, there's plenty going on, and we've got a lot more in-person meetings happening. And of course, you'll see that from some of the presentations today. So the delegates then, the last thing that I'll mention before I'm happy to answer a few questions, they discussed equity of workload, and that's across the whole effort of SCAR, because, you know, we need to better support what is essentially a volunteer workforce, and help with the translation and communication of what's going on in the science space to get it into the policy space as well. So there's actually quite a lot to do in that space. We'll of course work to make sure that the money follows where it's needed as well. And so there's quite a lot for this new executive committee to do coming in now. So we will meet as an executive committee actually next month. So normally by now the incoming president would have said, well, this is the vice president for science and this is the vice president for administration. And actually I'm looking to develop with the new vice presidents a bit more of an equitable workload. So we might subdivide the tasks a bit differently and make sure we can actually get back and help the teams that need it, that are also volunteers.
So yeah, kia ora everybody, and congrats, Gary. This is the first time we've had a New Zealand president of SCAR in the last 40 years, I believe. And, you know, it's an important time given a lot of the shared sort of global issues we have to address in SCAR. So, you know, important time, and great to have your sort of strategic leadership, and great to see the dominance of geology at last. No, joking about that. But I know you'll be fair and equitable. Okay, so Peter and Robin have asked me to talk about one of the strategic research programs, which happens to be SCAR's largest one. We now have 4. And so I am the co-chair, along with Florence Corleone in Italy, of INSTANT, which is Instabilities and Thresholds in Antarctica, really looking at better quantifying and understanding the Antarctic contribution to global sea level change. So in the past, what's happening right now, and specifically, can we do a better job in estimating the contribution of the Antarctic ice sheet as it melts under a future warming world and contributes to global sea level rise? So we're very transdisciplinary. We have membership from the physical sciences, from the geological sciences, and the biological sciences, and that's a hallmark of a SCAR strategic research program, to bring that systems type thinking to the problem. So we're a large group. We've got 360 members, and to put that in context, not all of them were at the OSC in Pukon, but I believe the OSC in Pukon was a little over 1,000, maybe 1,200 participants. Gary can correct me if I'm wrong. And we had a meeting last year where we had about 300 of our members turn up, and that was in Italy. And a number of our students, early career scientists, and Kiwi Antarcticans were there, and I'll talk a bit more about that. But the main focus we have is to understand the interactions that the atmosphere and the ocean and the solid Earth are having with the ice sheet. So those interactions, we need to understand that combined system to get a better appreciation of how the Antarctic ice sheet might respond to changes in the Earth system in the past, but particularly in the future. And the reason we want to do that is to improve the performance and skill of ice sheet models, which are key to our future projections, and really trying and reduce the uncertainty and understand what are the key processes that are controlling the rate of mass loss of that ice sheet. And even if we can't reduce the uncertainty, to better understand the uncertainty in a way that we can explain it to decision makers and stakeholders. So that brings me to the third part of the program, which is really where we engage and communicate with users of risk information, of climate risk information, such as sea level projections. And we engage and we communicate with the public, so they're better informed as well. So there's a number of case studies that are underway at the moment where we're actively engaging with coastal communities and users and practitioners, as well as with the treaty and COMNAP. The treaty parties particularly want to know how Antarctic sea level, how sea level around the Antarctic margin will change. And it's a very complicated thing. And in some places it'll go up, and some places it'll go down. And where you have a jetty, a wharf, or infrastructure in the ocean, or where you need access to a base, even where you have sea ice and penguin colonies, this is important information to know. Of course, it's the 1 billion people on this planet who will be impacted by sea level rise by the end of the century that also would like some better information about what we're all in for. So the overall goal was to bridge with society to bridge with communities, to bridge with practitioners, to better anticipate and assess the risk of sea level rise, so that we can manage it and adapt to it, and we can evaluate mitigation pathways as well. We want to know a safe landing climate for Earth that keeps the ice sheets intact and minimizes sea level rise. So there's an important mitigation aspect to that. Okay, won't get too deep into this, but the core of the issue really is the elements of the Antarctic ice sheet. It's grounded ice sheet, the big East Antarctic ice sheet here, and it's marine-based ice sheets, the parts of the ice sheet sitting below sea level in West Antarctica and some of the basins of East Antarctica that we're particularly worried about. And the science so far, the knowledge we have, suggests that these particular parts of the ice sheet could respond in an abrupt, fast, and non-linear way. So difficult to predict. And so that's really our wheelhouse, is dealing with the marine-based ice sheets and getting a better understanding of how they'll contribute in the future. So I'm just moving this little panel around a bit so I can see things, but I've got, just go back. I've got a cartoon here showing the ice sheet sitting on bedrock. So we're interested in what's happening to the bedrock, the geothermal heat flux, volcanoes, those sort of things. We're interested in what's happening in the atmosphere, the top-down melting, and we're interested in what the ocean circulation around the edges of the ice sheet are doing. And those three interfaces, or boundaries, if you like, are key to understand for better understanding future dynamics. So the first one we talk about is the marine ice sheet instability, which occurs as, for example, the West Antarctic ice sheet, which sits in a big bowl grounded below sea level, about 2 kilometers below sea level. And these instabilities are mainly responding to ocean forcing. So the ocean's warming. We know that the majority of the heat from global warming has gone into the ocean, and the majority of it is in the Southern Ocean. And that warm ocean is getting up into the cavities, the ice shelves, and around the edge of the ice sheet, thinning the ice sheet. And so once the ice sheet sort of loses its grip on the edge and starts to retreat into this basin, there's a self-reinforcing process called marine ice sheet instability that potentially means you'll lose the whole of that sector, or the West Antarctic ice sheet even, and it becomes unstoppable. So it's a tipping point. So that's one of the processes which is incorporated into some ice sheet models used for future projections. The other one is what we call marine ice cliff instability. And this is where you lose the ice shelves. So the ice shelves are the floating extension of the margin as it flows out onto the ocean. The Ross Ice Shelf, of course, we're all familiar with. If the ice shelves go, and they can go catastrophically, we've seen that, this hydrofracturing process where they literally explode due to surface warming and cavitation in meltwater cracks and that sort of thing, but also the nibbling away underneath and the thinning of the basal melting as well. So if the ice shelves go quickly, then there is this concept that the ice cliffs left, could just topple like dominoes, very rapidly causing the ice mass to discharge into the ocean. Now, this process is only incorporated into one model so far, and it's highly controversial, and it is one of the areas we're really working on. How important is ice cliff instability? Does it matter to the extent that it may? And those of you who have followed the latest IPCC report will be aware that we have projections for future sea level rise that are based on processes known with medium confidence. And then we have an extra dashed line, which is like an extreme sea level rise scenario based on a model that has this ice cliff collapse process in it. And so that gives significantly higher rates of sea level rise. In fact, the IPCC says what is the wording? It is that 2 meters is something around 2 meters being possible. So of sea level rise by the end of the century and 15 meters by 2300 if these low confidence processes come into play. So that obviously provides a bit of a head scratcher if you're a decision maker, particularly as you look out towards the end of the century about how high your seawall should be, how high your runway should be at your airport above sea level. And so that's really, one of the big focuses of our group. And that's an example of that deep uncertainty, we call it, with time. These dashed lines you're about to see are you've got the different scenarios here. The brown is the 4 degrees of global warming. And by 2100, with medium confidence, we would say we're going to get about 1 meter. But if we factor in the ice cliff impact on Antarctica, we can't rule out 2 meters by the end of the century. And those are those dashed lines. And it just gets worse as we head off into the next centuries. Now, none of this is really new to us as paleoclimatologists. And so the current program instant evolved from the previous program, which was the Past Antarctic Ice Sheets program. And what we learned under that program was that we've been there before. We know what the Antarctic ice sheet does in response to 1.5 to 2 degrees of global warming. And this is a big focus of the SWACE 2C project that Richard Levy and Molly Patterson are leading. The drilling that will happen this season is to figure out what happened to the Antarctic ice sheet with 1.5 to 2 degrees of global warming. And the evidence we have today suggests that West Antarctica most likely disappeared. We don't know that for sure. There is some conflicting evidence. And that sea levels with the Greenland contribution could have been up to 9 meters higher. I've just got to talk about the Pliocene. As you know, this was the Andrel project where we demonstrated and other work that's been done on far field records that you essentially lose all the marine-based ice sheets. You get 20 meters of sea level rise if you keep warming above 2 degrees. So, yeah, I mean, we're split up in this group into various themes and subcommittees, depending on your area of interest with your particular process you might be interested in, whether it's in the atmosphere, the ocean, or the solid earth and its interactions with the ice sheet. It's somewhere on this complicated diagram. And so if you're interested in that and you haven't already joined Instant, you're more than welcome to find yourself a home in one of those groups. We had our meeting. We're pretty proud of our diversity. This was last year in Trieste in Italy. And you can see we've got 40% of ECRs, we've got 40% women, and we've got 20% modelers from a range of countries. So a really dynamic and energetic, fun group. Conference was great. I won't dwell on that. I'll just skip some of these slides. But we did have a day dedicated to that interface between science and policy, where we invited decision makers, we invited IPCC, COP, UNFCCC people, we invited sea level practitioners who work, on coastal zone management. And we had artists and we had writers. So it was a really interesting day. So we're building capacity. There's some of our brilliant minds. The one in the middle there, the circle in the middle, that's Sally. We funded her as an inaugural fellow. She's just written a paper in Science about how octopus DNA can be used to reconstruct whether the West Antarctic ice sheet had collapsed 125,000 years ago. So she says, yes, it did. But, that's DNA. Now we need to drill it and see it for ourselves. And that's what Richard's team will be doing. We do a lot of policy interface work with the UN, the COP meetings. We attend those. We attend treaty. We contributed to this book in the middle, which is an update of Antarctic climate change and environment. And it really identifies some priorities that Gary was referring to in the strategy, the SCAR strategy, where we really must focus our energy and resources, because these are questions that need to be answered for societal protection, mitigation, and adaptation. Future, we've got a special issue happening. So we're 4 years in. We've got another 4 years to go. So please join us. We need fresh blood. We will continue to really emphasize this policy to science to policy to action side of things. And we're really a facilitation group. In the past, we've helped facilitate some major ocean drilling and drilling programs around Antarctica. The couple of initiatives right now, one is called RINGS, in which we'll be taking the RINGS group, supported by us, will do geophysical observations to get much needed data and observations to improve the models. And there's a number of big initiatives leading up to IPY we'll be part of and supporting. We're working very closely with the ice sheet modelling community to try and improve those models, particularly the ISMIP group, which is CLIC, which is part of the World Climate Research Program. Sorry, so many acronyms. And finally, Robin, and Gary referred to this, it hasn't, I don't think it's actually been approved yet by the delegates, but there is going to be a group to focus on emerging policy relevant issues. And one of them that's really started to become important is the polar geoengineering, the potential for tinkering with the polar regions to try and slow down the impacts of climate change on them. So some really quite exciting and relevant, policy relevant work that our glaciologists, sedimentologists and scientists are working on. Thank you very much.
Thank you very much from your distant contributions that came through very clearly. Thank you. Now we have Holly Winton, who will introduce herself and her contribution. Thank you.
Kia ora koutou, ko Holly toku ingoa. So I'm an atmospheric and ice core scientist, focusing mainly on Antarctica. And so Peter asked me to talk about one of the sort of themes that stood out for me for the conference. And definitely it was Antarctic extremes. They came through in so many different parts of the conference, from the sessions, the science parallel sessions. There's lots of Antarctic extreme talks, the science, and the number of sea ice sessions, also a lot in the climate sessions, past, future, and present climate. There was also quite a bit of discussion on extremes in the research programs. So these have previously been introduced, such as AntClim Now, looking at sort of near and future climate variability in Antarctica. And there was quite a bit of discussion there on extremes. And it even came up in the Paleo and Instant meeting as well. There was a workshop on extremes. This was an interdisciplinary approach to understanding the drivers and impacts. And this was particularly interesting. But first, I just thought it would be helpful to talk about or to put up the IPCC definition of extremes. So this is in the context of weather and climate. So this is the occurrence of a value of a weather or climate variable above or below a threshold value near the upper or lower end of the range of observed variables of that variable. And so this, the part in here that stands out is the range of observed values. And this is, as all Antarctic scientists, we know that we don't have very long observational records. So this is a real challenge for us, I think, when we're looking at extremes in these short records in Antarctica, in an area that does seem to be changing quite rapidly over the last decade. So then at the workshop, I'd say this was a 2-hour workshop, and we spent probably the bulk of the discussion talking about this, a definition of an extreme. What is an extreme in your particular field? And it was very clear that there is people use a whole range of different thresholds and definitions, and that there is no consensus at the moment. And it's very difficult to sort of come up with an index or a threshold that's applicable to every science area or research topic. So the question is, do we need standardized definitions? There's a big emphasis on this research at the moment. And so a lot of discussions really on the way forward. How do we define extremes in Antarctica? So this was an example that was actually shown at the workshop. And so I'd just like to thank the workshop organisers for putting this together. But this, you've probably heard this one. This was a mega heat wave in East Antarctica in March 2022. And it was associated with an atmospheric river. And so here you can see this is from Dome C, Concordia, in the centre of Antarctica up on the polar plateau. And this is the temperature record. So it goes back from 1991 to 2020. So again, it's quite a short observational record. But this is what we've got from the site. And in red is that 2022 year with this extreme temperature increase, and that was about 30 to 40 degree temperature anomaly. So a big jump that clearly had not been seen within that observational record before. And this was driven by these atmospheric rivers that come down from subtropics and mid-latitude, bringing very concentrated air mass full of warm, moist air. And you can see that in this red image here of that intruding onto the plateau. So this extreme event impacted a large portion of the Antarctic, as you can see in pink there, and it had a range of impacts on Antarctica. So there was the big temperature increase, there was widespread rain was observed, surface melt, and very high snowfall occurring. So on the bottom, this is the blue is that the snowfall associated with that event, compared to on the right, the mean snowfall for the record. And so there were a lot of other impacts, but I thought one to note was that water isotope, so measurements looking at water isotopes at the site at Dome C Concordia, there was a large peak in these water isotopes. So that's really interesting because that is where we get our temperature records in the ice cores from. And we haven't really observed this before. So the question as an ice core scientist is, well, for me, is do the ice cores record these extreme events? Because of course that's really important for us to put them into context. So then the other example is sea ice. And on the right is a picture, is a figure of sea ice extent in the Ross Sea, and this looks very similar to similar pattern to wider Antarctic sea ice. And it shows the observational record, satellite record, relatively short, which has been increasing until about 2016 when there was this dramatic drop, and again record low sea ice year in 2023. And on the left, you can see that 2023 line in red, and it's this extreme year well below the average. And so again, we've only got a couple of these extreme years to go by, 2016, 2023. So it's very difficult for us to sort of understand the impacts on ecosystems and the rest of the climate with only a couple of these extremes to go by. So then, of course, what's the role of the paleo record in this? And can particularly high resolution records such as ice cores help to understand these extremes and the impacts? So there was a fantastic presentation that really stood out to me was from Goose, and he presented a new sea ice reconstruction. It went from 1958 to present, so just extending the satellite record by a couple of decades. This was based on data simulation, so long-term simulations and large ensembles with some station-based records. And this was particularly interesting because this new reconstruction showed a sea ice drop in the early 1970s that was a comparable magnitude to that 2016 low. So it's really important for us to be able to make these reconstructions to put these lows into context. And then something throughout the conference that was, I think we're thinking a lot about is we've got these lows. Do we see them in the ice cores? And particularly that's been challenging because a lot of the ice core records ended in 2000 that are used for these reconstructions. But luckily we've had a few new cores drilled last season and other nations have been drilling cores. And so the question is, do we see these, for example, for the sea ice, do we see the 2016 and 2020 extremes in the ice cores? There are, of course, challenges with this related to resolution. And the good example would be extreme precipitation events. This image shows the dominant role of these extreme precipitation events on the annual precipitation from all over Antarctica. And this is something we've been thinking about for quite a while, not just the last few years. But the majority of snowfall in Antarctica throughout a year occurs in just a couple of dumps. So in a couple of days, we're getting the majority of the snowfall. So this really does have implications for our ice core records because we just don't see these extreme events. And so going forward, I think there's a lot of questions, and this workshop is pulling together a group of people to write a white paper, start thinking about definitions and approaches going forward.
Right, so I'm the last speaker here, something a little bit different from me. So Peter said, could you talk about why this conference is a little bit special? And I thought there's two parts to that. SCAR conferences, I think, are special because they bring together so many different sciences and really focusing in on the key questions. And this one in particular because of its title, Crossroads for a New Hope. So I'm going to talk a little bit about my experience going to this conference, and I wanted to capture what it was like there and then convey that to my first year class. But before I get to that, the conference itself, 1,500 scientists or 1,500 Antarctic experts, not just the scientists, from 55 different countries. So there's all of the SCAR countries, I think 44, 46, Gary said, or Tim said. There's 57 countries in the Antarctic Treaty. So actually, nearly all of the Antarctic Treaty countries are represented there. That's a pretty good representation from around the world. That's my first takeaway from that. The other things I wanted to get across to the first year class were that it's really truly a multidisciplinary meeting. The biologists are there, the geologists are there, the atmospheric scientists are there, the oceanographers, the ice sheet modelers, and more. So it's not just your run-of-the-mill conference talking to your community. There really is a bit of cross-pollination going on. And the thing that really struck me was that science is converging around the issue of climate change, perhaps unsurprisingly. The biologists are talking about it, the geologists are talking about it, everybody's talking about the issue of climate change, and that it's clear Antarctica is now entering into this period of extreme events and rapid change. And so I think that's really important, and it underlined to me how apt the title was, Crossroads for a New Hope. The different sciences coming together, converging on the issue, and sort of moving beyond the question of, is climate change happening? Yes, it is. And we're seeing that across all these different spheres of the Earth system. What are we going to do about it? What does this community need to say to the rest of the world? Which flags should we be raising? What should we be bringing from the science to inform policy? So the crossroads for a new hope, bringing the science to address the question. And I really wanted to get that message across to the first years. I wanted to impress upon them the excitement of being at one of these meetings, an in-person meeting, and perhaps to justify why we go to the effort, the expense, and the carbon of all going to Chile for a meeting. In a class where I'd spent quite a bit of time talking to the students about carbon and the dire state of the world and how carbon's going up, and we know why. And then on the next breath, I say, oh, by the way, in the mid-trimester break, I'm going to Chile for a conference. And you can see them thinking, hang on a minute, how does that add up? And it's a good question, and it's a fair question, and I'm quite pleased they asked that. So I wanted to come back and say, we go to these meetings because this is really where things come together. And we can do a little bit of that online, and we do more and more of that, certainly since COVID. But getting people into the same room and bringing the human factor into it, I really think helps make stuff happen. So it's exciting, it's busy, there's so much going on, and I tried to impress my students with, there are 4 days of the business meetings, the expert groups, the action groups, the research programs like Instant that Tim was talking about. Then there's the Open Science Conference, 5 days, more than 1,600 abstracts submitted, 50 different sessions, several different concurrent sessions going on at the same time, with 4 or 5 talks happening at the same time across multiple rooms. There's lots to see, there's lots to hear. I personally made a point of dropping into a few sessions that I normally wouldn't go to, and I heard about microplastics in Antarctica. I heard about extreme events. I heard about biology, atmospheric science. And so it's neat for broadening your own horizons. Poster sessions, hundreds of posters, dedicated poster sessions, and you can see here, these were very, very busy events. In fact, it was a struggle to get around all of the posters. 5 mini symposiums, 28 workshops, 4 side events, including IPY 2032 preparation. Some social events, because if you're going to get together, you may as well have some social events. The icebreaker, the Antarctic Fest, the dinner, the final party, bringing that human connection together, making the most of getting people there. And I think most of the people that attended this meeting knew the cost, the expense, and the carbon footprint of going. So they're very focused. They're away from their own office, they're away from their own troubles, and they want to make it count. So there's good science going on, there's good collaborations, there's projects being born of these things. So beyond that, I wanted to describe to the students why SCAR is an important organisation and why getting all of the SCAR members together was very valuable. So a bit of the history, a bit of the vision of SCAR to carry out good science in Antarctica. And in fact, I'm wearing the SCAR t-shirt today, 1958, prepare a plan for the exploration, scientific exploration of Antarctica. And so over 60 years later, that has developed and grown. And here's the vision statement from the 2023-2028 document that Gary mentioned: to create a legacy for Antarctic science and knowledge that addresses the foundational requirement for discerning a path to a more sustainable future for our planet. And this stuff, I think, really speaks to the students. This isn't just going on a jolly to a science conference. This is about focusing on the big issues. So SCAR is not just about Antarctica, it's about the Southern Ocean and about how Antarctica is important in the wider Earth system. And it's not just about the science, it's about bringing the science and turning that into some policy relevant information, advice to the Antarctic Treaty System, the IPCC, ChemLAR, and those others. So I think that is important, and being able to convey that to the students is important. So my view is that, SCAR's mission is now even more relevant and urgent than ever before, and definitely worth an in-person meeting. And on that note, congratulations to Gary. That's good news for SCAR, I think. It's good news for New Zealand. It's good news for geoscience. And if I've got a couple of minutes, I made a little video. And this is part of a video postcards that I make for my students wherever I go. It's kind of a little bit of fun. It's off the top of my head, just to try and convey to them what it's like on the ground, maybe a little bit of the excitement of what's going on.
0132 from Pucón in central Chile. I'm in the Araucania Lakes district on the foothills of the Andes Mountains in central Chile. And this is an amazing wee town here, pretty cold at the moment, bit of snow on the hills and including on the sides of Villarrica volcano, which is just on the outskirts of town. This is, it's a beautiful area. It's the homeland of the indigenous Mapuche people, and this is sort of like the adventure tourism capital of Chile, kind of like Queenstown in New Zealand. But I'm here at the Scientific Committee on Antarctic Research Open Science Conference. And as you can see in the sign here, it says Crossroads for a New Hope. So this is a meeting of over 1,500 scientists, but also Antarctic managers, so program managers, representatives from the Antarctic Treaty, logistics organisers, lots of different people involved in doing science in Antarctica. So it's a really collaborative event where not only is the science being presented, the latest science, but it's also being translated into policy relevant information that is provided by SCAR to the Antarctic Treaty System. So that ensures that the science is informing how we operate in Antarctica and making sure we're doing relevant future focused science. So pretty exciting atmosphere here. It's really satisfying to see that process happening. For me personally, I am running a workshop here of one of the expert groups of SCAR looking at geo-heritage and geoconservation, and that's identifying sites that have got particular scientific value in Antarctica and then identifying whether they need any protection status underneath the Antarctic Treaty. I'm also presenting some results from some scientific work that I've been working on, so drill cores from beneath the Ross Ice Shelf in Antarctica and looking at the sedimentology and what that can tell us about the past behaviour of those ice sheets. So pretty neat to be here, soaking up the atmosphere and seeing science in action, but science informing policy for the future. All right, see you soon.
I was going to ask if, in terms of your instant project, are there any big new initiatives that came out of your gathering there in Chile for a few days?
Yeah, we were asking ourselves the same question. You know, we've been at it 4 years and we've done a lot. There's always, you know, I didn't really highlight it, but there's always interesting science being done and we're chipping away at the issue. But I would say it's taken us 4 years to get into a situation where we're now really humming and well set up, connected in the policy space, but also connected up with the ice sheet modelers in a way I think we can make significant progress. It's not an easy problem to solve. The understanding of these processes, which ones are important and how to get them into models so you reduce those uncertainties is still, you know, we haven't achieved that yet. And now we've got the extreme events to layer on top of that as well. You know, if an atmospheric river hits West Antarctic ice shelves, like the one that Holly showed, if that hadn't been on East Antarctica, but it hit West Antarctica, we could have seen catastrophic ice shelf loss. And it could be those things that trigger the early warning signs of what's to come with the rest of the ice sheet. So it's really exciting times. So I don't want to use up too much time, except to say we're a work in progress at this stage.
The treaty meetings were somewhat fraught because of the issues around Russia and the Russia-Ukraine and the knock-on effect to how treaty people think about it all. Did that come into the SCAR side of things at all?
I can't speak for how the different nations made their different decisions, but certainly the discussion was focused on science and on the science plan of the, in this case, it was Belarus. So there was no discussion of the political situation, and that's SCAR's mandate, right? To keep away from the politics and keep focused on the science. So we did that, but of course, yes, I can't speak for what was in the minds of each of the different nations, but certainly the discussion at SCAR was focused on science and science plans.
Okay, that's always encouraging. Holly, have you got a working group on extremes, the definition of extremes now or something like that? What happened after your big workshop?
So they're synthesizing all the information, and I think there'll be a white paper that comes out of it. So people will get, there'll be a group that's formed, and they did actually talk about a potential SCAR working group.
Cliff, how did your students react to you? Did they accept the fact that you went to Chile for an intense scientific session with some jollies on the side?
I think we'll find out at the end of course evaluations. I hope so. You know, I decided if I was going to this meeting, I was going to turn the experience into a new lecture for the course. And it's a fun course this first year offering. I get lots of interesting people to come in and talk about all different aspects of Antarctica, from the science through to the Antarctic Treaty System, environmental management, discovery and arts, the whole lot. So being able to have the space and try and convey the excitement of being at the meeting, but then all the good stuff that happens when people do get together with a shared mission, I think they're convinced. I hope they're convinced. I think, you know, it's a hybrid world now. Most of these conferences are online as well as in person, but I'm still a big fan of getting people together in the same room. Stuff really happens. Conversations happen that wouldn't happen through a screen. In my own experience, I've been on this expert group of Geoheritage, and one of the people I've been working with is a Spanish scientist. He's an expert on geoheritage, Enrique. I've been working with him for over a year on Zoom meetings, but it was great to meet the guy and shake his hand. We went and had a beer and we talked about experience, we talked about family, the whole lot, and I'd say we're friends now. I think we're both even more motivated to keep doing good stuff.
Thanks everyone for participating and listening to our sessions on the meetings, and thanks to those of you who are remote. Thanks very much. Okay.